Hello everyone, we'll start chapter 1 sets exercise 1.2. Previously I did the sets introduction and exercise 1.1 and types of sets. You go and check it previous videos. Now we'll start sets exercise 1.2. First question we'll see. What is the first question is there? Which of the following are examples of null set? See, null set means a set does not contains any elements, we call it as a null set. Null set means a set does not contains any element is called as a null set. Now see here first question, what is that? Set of odd natural numbers divisible by 2. It is a null set or not, we should check. Odd natural numbers divisible by, see, odd natural numbers means what about 1, 3, 5, 7, 9 and so on. These are not divisible by 2. Yes sir. Odd numbers is does not divisible by 2. So we can write it is a set of odd numbers is a null set null set null set because no odd numbers no odd numbers is divisible by 2. No odd numbers is divisible by 2. See, set of odd numbers divisible by 2 means it is a null set because no odd numbers is divisible by 2. Next, set of even prime numbers. See, even prime numbers means what is there? Only 2 is there. So, if in a set any element is there means it is not a null set. It is not a null set. What is the reason? Because 2 is a 2 is an even prime number. 2 is an even prime number. 2 is an even prime number. Next question, see. X is a natural number. X is less than 5 and x is greater than 7. X is less than 5 means what you will get about? 1, 2, 3, 4. Greater than 7 means 8, 9 and so on it will get. See, simultaneously we can't get like this. X is less than 5, greater than 7. So it is not, it is a null set. It is a null set because no elements are there in set. No elements are there in set. In between no elements are there. X is greater than 5 means it will come this side. X is less than 5 means it will come 1, 2, 3, 4. Greater than 7 means 8, 9 like that. In between no numbers it will be there. So this set is null set. It is a null set because number of elements, because no elements are there in set. Next, y is such that y is a common point to any two parallel lines. See, parallel lines means the lines do not intersect each other. Common point means like this. If you wrote means here common point will be there. So here y is a common point. They are saying nowhere y point is lying here. So it is a null set because no common point lie in between parallel lines. No common point between parallel lines. Next, Next question, which of the following sets are finite or infinite? See, finite means which are countable, we can count. Infinite means uncountable, we can't count, that we call it as a infinite. Finite means countable numbers, infinite means uncountable elements. Now, the set of months of a year, set of months, how many months are there? For 12 months, 12 months we can count. So it is a finite set, it is a finite set because it is finite because 12, because 12 elements are countable, we can count this, 12 elements are countable. Next question we'll see, 1 2 3 and so on, we don't know where it is going. So it is a infinite set, it is a infinite set because here uncountable elements are there in set, the elements are there in set, so are there in set. Here we can't count and so on, they gave on, we don't know where it will go. So it is a infinite set because here uncountable elements are there in a set. Finite set, it is a finite set because countable elements in a countable number of elements in a set, elements in a set, that is 1 to 100, 1 to 100 we can count. Next, a set of positive integers greater than 100. See, greater than 100 means what you will get up? 101, 102, 103 and so on, we don't know where it is. So on, greater than 100 they gave, they didn't give condition up to here like that, so it is so on. So it is a infinite set, it is a infinite set, it is infinite set because uncountable number of elements in set, uncountable number of elements in set, it is an infinite set because uncountable number of elements in a set. Next question, the set of prime numbers less than 99. This set of prime numbers less than 99 means we can count what are the prime numbers are there less than 99. So it is a finite, it is a finite set because countable number of elements are there in set, countable number of elements are there in set, are there in set. Next question, state whether each of the following set is finite or infinite. See, next, a set of lines are parallel to x-axis. See, if you wrote Cartesian plane, this is x-axis means parallel to x-axis means how many, now we don't know how many lines we can draw, like in here also we can draw parallel to x-axis. So it is a infinite set, it is a infinite set because we can draw see set of lines which are parallel to the x-axis, means it is infinite set because we can draw uncountable parallel lines to the x-axis. Parallel lines to the x-axis means we can draw parallel lines, infinite number of lines we can draw to the x-axis. Next question, the set of letters in a English alphabet. Set of letters in a English alphabet, what you will get upon? A, B, C, D up to Z. 26 letters are there. 26 letters we can count. So it is a countable set. So it is a finite set. It is a finite set because it is countable set. We can count 26 English alphabets are there, we can count. Now see, the set of numbers which are multiples of 5. Multiples of 5 means what it will get upon? 5, 10, 15 and so on. We don't know where it will end. So we can't count this. So it is a infinite set. It is infinite set. It is infinite set because we cannot count the elements in a count the elements of multiple of 5 because we cannot count the multiples of 5. See, multiples of 5 means it will be going 5, 10, 15, 20 like that. We cannot count. So it is an infinite set because we cannot count the elements of 5, multiples of 5. Next, the set of animals living on the earth. Now see, the set of animals living on the earth means it is large number we will get, but we can count. So it is a finite set. It is a finite set because we can count. Now see, this set of circles passing through the origin. From origin passing through the circles means how many circles can pass? We don't know. Infinite number of circles can pass. So it is a infinite set. Infinite set because we cannot count the elements of circles passing through the circles passing through the origin, because we don't know how many circles, we don't know infinite number of circles can pass through the origin. Now we'll see next question. Question number 4. What is there about? Question number 4. In the following, state whether A is equals to B or not. A equal set means what about? Whatever the element A is in, there should be element B also. That we call it as a equal set. Now see, in A set, what is there upon? A, B, C, D is there. Here also D is there, C is there, B is there, A is there. You should remember one thing, in sets order does not matter. Like anything you can write A, B, C, D, you can write D, C, B, A. So these both are equal only because A, B, C, D in this set also it is there, in this set also it is there. So we can write A is equals to B. Next question, if you see, A is equals to 4, 8, 12, 16. B elements are 8, 14, 16, 18. Now see 4. 4 is there in B also. 8 is there in B also. 12. Now see, 12 belongs to A, but 12 does not belongs to B. So we can say A is not equals to B. A is not equals to B. Now see, A set what is there? 2, 4, 6, 8, 10. A set what is there? 2, 4, 6, 8, 10. B set what they given up? X is a positive even integer and x is less than or equals to 10. Less even positive integers means what you will get up? 2, 4, 6, 8. Here less than or equals to 10 means 10 also included. So here A is equals to B. Yes, A is equals to B. Now A what is there up? X is a multiple of 10. Multiple of 10 means what you will get? 10, 20, 30 and so on. Here B set what is there? 10, 15, 20, 25 and so on. Now see, here 10, 20 is there. Here 15 is there. A is not equals to B because 15 belongs to B. 15 belongs to B, but 15 does not belongs to B because why? 15 is there in B. 15 does not belongs to A. 15 belongs to B, but 15 does not belongs to A. So therefore A is not equals to B. Now, are the following pair of sets equal? Give reason. If the sets are equal means we should give the reason. They are see, A 2, 3, B is what is there upon x is to x. Solution for x square plus 5x plus 6 is equals to 0. If you do splitting middle term method means 2x plus 3x plus 6 is equals to 0. Here what you will get about x plus x, if you take common means x plus 2 plus 3, x plus 2 is equals to 0. So x plus 2, x plus 3 is equals to 0. So x is equals to minus 2, x is equals to minus 3. Here A set what is there? 2, 3 is there. B set what is there? Minus 2, minus 3. So here 2, 3 is there. Here minus 2, minus 3 is there. So here A is not equals to B because 2 belongs to A, 2 does not belongs to B. Because 2 belongs to A, 2 does not belongs to B. We'll see next question. What is there upon? X is a letter in the world of follow. Follow A means how we will write upon? We should not repeat the elements F, O, L, W. B what is there? W, O, L, F. So here A is equals to B. Why? Because there are elements A is in B, elements of B is in A, so we can say A is equals to B. We will see next 6th question. Yes, see 6th question what is there upon? From the sets of the given below, select equal sets. Select equal sets. Equal sets means now A is equals to 2, 4, 8, 12. B is equals to, now we will check for A. In A how many elements are there? 4 elements are there. B also 4 elements, but see 1, 2, 3, 4. So A is not equals to B. Next, from A to C means 4, 8, 12, 14. Here what is there about 2? Here 2 is not there. So A is not equals to C. Now A and D if you compare means here 3 is there. In this set 3 is not there. So A is not equals to C also. Here B. A is not equals to B. Now if you check B. 1, 2, 3, 4. Here see 1, 2, 3, 4. Here what is there above? 4, 8, 12, 14. So these both are not equal. Here see 3, 1, 4, 2. Here also 1, 2, 3, 4 is there. Here also 1, 2, 3, 4 is there. So we can write B is equals to C. These are solutions. Here B is equals to, we can write 1, 2, 3, 4 are there. Here also 1, 2, 3, 4 are there. So sorry, B is equals to D. B is equals to D. Now B is equals to E. Why? Because we cannot compare here. Here only 2 elements are there. Here 4 elements are there. No need to compare. Here C 4, 8, 12, 14. C is also not equal to anything. Now if we see this one, E minus 1, 1 is there. Here 0 comma is there. No, not equal. Not equal. Here see G 1 comma minus 1 is there. Here minus 1 comma 1 is there. So we can write E is equals to G. Then here 0 comma A is there. 0 comma A set not is there. So this how B is equals to D and E is equals to Z are the equal sets. Now question exercise 1.2 is completed. We will start 1.3 introduction in next video. Thank you for watching.